All right, now let's see the Factory IO environment. So if you have this software, the good thing is you also have an RFID read-write head in the software. So you can use it here, and now the pallets and the boxes have RFID tag attached to it. So this can be used to read the information from the box, and you can use this information in your PLC. So in this environment, I'm just using an emitter, which is emitting the boxes, a conveyor and remover, and with just one RFID read-write head. Okay, nothing complicated. So how this RFID works in Factory IO, it's a bit different than the real RFID read-write head. Of course, because many companies, many manufacturers has a different way of reading and writing the data. But yeah, this is a little bit different, but no worries. We can integrate this Factory IO RFID in our current logic to read the information and store in the same buffer which we are using. That's the advantage. And if you know how to integrate different technologies and using the same logic, that's the way to have a good learning. Okay. So how does this work? In this, I'm not using all the functions. I'm just using the status, and the status currently is 1. Read data. This is the data reading from the RFID tag, and execution command. Now, what is a status? Now, if you open the RFID manual in the Factory IO logic, status 1 means written successfully. So status 1 means the tag is present and it's the reading or writing command is successfully executed. And this execute command, this is a Boolean, and I have to keep pressing it so that I will get the tag information. For example, right now you will see there is no updation of this information. But if this object comes in front of the tag, I have to press it once, and then you will see this is updated. And again, if it is true, it will not update again. It has to be like a pulse mode, like this. So this is the way how this logic works in real games. Now you can see that the tag is updated 6266. And again, you will see this will be updated. So I have to make this on and off all the time. This I can do very easily using the system clock pulses in my PLC. That's it. Just make it on and off all the time. Read the tag information, and the status 1 means tag is present and it's written. So I have to make sure the status is 1. All right, so we have just 3 information. So now I'll go to its driver settings. Here you will see read data. This is coming in double integer. So we were using normal integer in our 16-bit integer in our real world RFID application, but here it's double, so we have to do some changes. Status is also in double, so we have to make some changes as well. And the execute command is at Q1.0. I'm using it here, so I'm just using the command read data and the status. So I have to use this information in my PLC tags. So going back here, and I will make another tag table and rename that to RFID real games, because it's coming from the real games. Open this one, and now we have to see what we have to write. The first one is read data. So I will write, because it's coming from real games, I would prefer to write real games RFID value. Okay, now this value is coming at ID 200. Okay, so I have to change this to ID 200, and this is double int. Perfect. Second value is status. So again, real games RFID status. This is 204, or let me check. Yeah, 204. The third tag is execute command, which is Q1.0. Real games execute command. This is Boolean, and this is Q1.0. Perfect. So we have 3 tags defined here. Now coming back to the read values. So you know that here we were reading the values. So basically we were reading the values from real RFID head to our RFID data. So if I go back to my RFID data here I have to write another, oh, that's a problem. this was defined in the data type, so I have to go and change my data type. So in my input, this is the read values. I will take another read value. I will write real games. What was that? RFID? What did I write? Real games RFID value. Okay. Real games underscore RFID underscore value. So underscore value. This was coming in double int. So this is what I need, and I also need real game RFID status. Real games RFID status, that was also double int, and we have one output. Real games command execute. So real games, you don't need it because if you're just using the hardware, this is just for the explanation that how to integrate software. Command execute or execute command, doesn't matter. This is also Boolean. So now this is defined in data type. I just need to compile it again. I have to go offline. Compile it. So this is compiled. Now let's open it here. Now if you see in this input, this is my RFID data. This is updated with real games values. Now I will write a comment reading values from real games. So since we are reading the values from real games tag to my DB, so this will come here first, value, and this will come here as well. Now we will open the tags. So maybe minimize this one, and our tags are here. So the value will come from here, ID 200, my DB, and this will come from here, status. Perfect. This is reading the value. Now we have to write the values. So I will close this one, open the write function, take it out, write values to real games. Perfect. Now for writing the value, we just have one value which we have to write. So which is, this is command execute. This will be written to the PLC tag. So open the PLC tag first. This comes here. This will be closed. And this we are going to write here. Perfect. So reading, writing the value is complete. Now I just want to download this logic and just to check if we are getting these values in our DB or not. Then we will proceed with the logic. So reinitialize, load. Finish. RFID data. Let's monitor it. So currently we see there is no value because we have to execute the command. So let's see if we get the value. I will execute it. Oh, this should come the value. I don't see the values. Let's see where is the problem. This we don't need. Okay, let me go to the main block. Everything looks okay. Oh, sorry, I did not connect my driver. Sorry about that. I have to make it connect. Yeah, now it's connected. Now we should be getting the values. So now you can see that here, 6320. And if I do it again, 27, though this value is coming here, status is 1, but I'm just doing it manually, but I will do it with the logic again. So this is just to check if you're getting the values. So that's fine. Now what we have to do, we have to make changes so that this value should go into the buffer, but not this RFID value. This value should go. So a little bit changes. Now let's go to the buffer data. Okay, let's first do the simple thing. We have to execute the real games command. I can do that next to this network. So I'll write executing real games buffer command. Okay, not buffer command, execute command. Executing real game command, that's fine. Now, as I told you, I need to keep pressing this button all the time. What I can do is, I can just take a PLC clock bit and I think take the output. Now in the output, if you remember, we have made a tag, a real game tag, which was real game execute command tag. So I can just basically drag it here, or I can do it from the RFID DB, which was here, sorry. So this was the command. Oops, where's that? Yep. This comes here. And we can use here now the clock pulse from the PLC. So if I go to device configuration, oh boy, wait a second. Device configuration, and we check its property. And here you can see, where do I find it? System and clock memory. So I have defined it. This is my clock memory. And I can use this M0.1, which is 5 cycles per second. Pretty good. So M0.1 is a good idea. So let's take it here. M0.1. So this is a clock pulse. So this will keep on giving pulses to my output. So let's try that. So I will download this logic. So we are just proceeding step by step. I don't know if I'm doing very slow or if I'm very fast. So now this is giving the pulses, and let's check the value in RFID data. Input. Yeah, we have to see if this value get updated automatically. 6328. Oh, nothing. Oh, wait, I should not force it. Now you will see. So this is being updated now. 6351, next should be 6352. So this is working fine, pretty nice. So I will pause this video here, or I will continue the rest of the logic in the next video because it's getting very long. I don't like long videos because sometimes it will make you sleep. So let's continue in the next video. How do I integrate this value in the buffer? See you soon.